Very good morning, students. Welcome back to physics practicals for second year. Say, actually, we finished three practicals, and let us. I want to say the next practical that is related to the spring constant. So, we need to find the force constant by using a force constant of a spring. So that here for this experiment we require, so our aim is we need to find a force constant of a given a helical spring by the oscillation method. So for this purpose required one helical structure of a spring, and for this helical structure of a spring is the diameter is equal to, which we can say 1 or 1.5 centimeter. Diameter is 1 or 1.5 centimeter it is. This is the helical structure of a spring, and which is to be connected to the one retard stand, and this stand is, see, have a scale. There is a scale is given to measure the length of the spring, and here there are some slotted weights, so that here we can say each slot is, it is related to the 50 grams, like we can take 50 grams, so that we require some slotted weights. And come to the point is, see, another one is the stop clock. We require a stop clock also, and this stop clock should be that equal to accuracy equal to 0.01 second, or we can say 0.1 second accuracy of a stop clock. Now actually what we need to find? We need to find a spring constant of a given a helical structure of a spring. Now there is a formula, that is k is equal to 4 pi square into m2 minus m1 by t2 square minus t1 square. It is a force constant k. We know k because already in the first year we did this formula. So from that formula now we need to find a k, 4 pi square of m2 minus m1 by t2 square minus t1 square. And here we need to get, see, m1 and m2 are nothing but we are using the masses, that masses here which is we are hanging here, the masses we are hanging here, that is the one thing. And in the I want to say time period of a loaded spring, or we can say time period of a loaded spring, we can say t1 is equal to 2 pi into root over m0 by 3 plus m1 by k1. Sir, what is m0? M0 is nothing but a mass of the spring. Yes, of course we can take the mass of the spring by using a like a physical balance. From there we should get a mass of the spring. That's what we can call m0 by 3. M1 is nothing but a, first of all we are taking the reading, or we are taking the mass in the slot, so that reading is m1. See, substituting this we'll get the t1, but we don't know k1, no, that is a spring constant. So that k1, k2, k3 we need to find. So for that purpose there is a tabular form we can take like this: serial number and mass of the load in kg. We must be taking the load must be in the kgs. So it is the first column, and the time period, time taken for the 20 oscillations. So when there is a load is added, therefore we should count the 20 oscillations. I'll show you. And here we should take a trial 1, trial 2, trial 3. See, for the same slot, for the same weight, we should take the three trials for the same mass. It is x, y, z, and mean we should get x plus y plus z by 3. And the time period for the 20 oscillations, because we are taking the 20 oscillation, no, capital T is equal to, this mean is gives as small t. This mean is gives the small t. Therefore, capital T is nothing but a small t by 20, because we are taking the 20 oscillations. We need to find a k value, so that the k value we need to find. No? So before that I'll tell you first of all how to do the experiment, then after we'll see. Let us actually, spring is, now it is empty, there is no slots. So you take a slot. First of all we need to take, see, the first reading I am taking here. So you take a 200, that mean here each carries a 50 gram, no? Yes, you see here it is clearly mentioned here 50 grams. Here it is the 50 grams is given. Like you take a 4 here, because we are starting from 200 grams, right? It is a 50 gram. Another one is added here. Yes, of course, 100 now. Let us now take another one, 150. Another one is 200. Yeah. Now you add here and here like it is to be stretched like this. So this is the, see, before this added, this is we can call natural length of the spring, natural length. Now let us, when we load is added, of course there is a spring is stretched because it's a helical structure of a spring. For this spring we need to find a force constant. So now force constant, there is a formula we know, K is equal to, need to find K, 4 pi square m2 minus m1 by t2 square minus t1 square. This is our aim. Now there is a load added, right? Now let us, you take a stop clock. Now you write in the tabular form. There will be a load is how much is added here. For first trial it is 200 grams actually, but we are taking in the kg. That's what here you write is 10 power minus 3. Now for trial 1 I am telling, that is about a trial 1. You take as the trial 1. So it is to be like it is, you pull it down like this. Because it is in a horizontal, no? You pull it downward and you release it. Slowly we can do. See, when we are pulling down and released it, therefore it makes a 20 oscillation. We need to count a 20. So this is actually, from this is, it is an extreme and this is an next extreme and it is in a mean position. So now while we are starting or while we are count starts, so that you on, let us on the stop clock. Let us, now I am counting, say let us stop the clock and you again you on it. Yes, count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop the clock and note down the reading. That accuracy I told you very clear, 0.01 second, or we can say it is a 0.1 second. So that after counting stops, then you stop the clock. Therefore here we may get the approximately for that value for 20 oscillations. The answer is maybe it is approximately, roughly I am giving, because right here it is approximately 14.31 it is. First one it is 14.31 seconds, trial one it is, and you repeat it again you repeat it, again you start 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Again stop the clock and note down the reading. Approximately it is almost will get the same. It is roughly we can take as little variation will get 14.28, and third also trial you do it, almost it is also will get the same thing, 14.28 like this. So you take an average 14.31 plus 14.28 plus 14.28 divided by 3, and then after, now it is a first experiment. Now you change the slat, that mean here you remove this, you add one more 50 gram here, that's what we can say, it is a 250 right here. Now for the second one I am taking your wish. You want to start from 100 also, no problem. Better you start from 200 because that is to be oscillates in a good manner. If I take 100, it cannot be oscillate. That's what you go for the 200, and next one is 250. Again you like pull it. Now the helical structure of a spring is again it is stretched down, and you pull it down, and again you start count 1, 2, 3, like up to 20 oscillations we need to count here. Therefore we'll get the other reading which is equal to like 20 oscillations, right? So that here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop the clock and again note down the reading. See, here it is showing what it is, approximately 16.53. So again you do the same. Yes, you want to stop it, and again you pull it down and again you count. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop the clock and note it, approximately it is also 16 point of some 51, right? Like third one also you take, you can also write it is near very close to 16.57 also we can. This is for 250 gram. Suppose you want to go for the other one, yes, you take a one more slat, so that here we will get the, for 250 is over, no, you go for the 300, so that you add one more slat here, you remove it and you add one more. Now you look at 50, 50, 50, 50, 50, 50, so 100, 100, 100, 300 it is now. Now you add and again, so we need to count it same again, so here pull it down and release. Yes, you start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop the clock, and it is approximately, it is showing a, here it is 18.06. Like second also we may get 18.07, 18.05 you take. Now here you add a 3, 14.3. Now calculation, we can take a calculation like this. Suppose 14.31 plus 14.28 plus 14.28. You add these 3 and divided by 3. So we will get the one mean value, that is a small t. So let us, I'll calculate it and I'll tell you. See, approximately we may get the 14.28 it is. This is will be 14.28, the first one. Here also, second one also we may get the approximately 16.57 and here 18.05 it is. Now capital T is required now, because T1 it is. For M1 mass, 14.28 divided by 20 you take. T2 is equal to 16.57 divided by 20. T3 is equal to 18.05 divided by 20 you take. So we may get the 20 for 20 oscillations time period. Now we are writing, so that it is approximately, first one you say 0.71 it is, 0.71 it is, 14.28 divided by 20 we may get like this, and go for the second one, it is 0.82, 0.82, and third one 18.05 divided by 20, no, so that it is maybe 0.94, 0.904 it is. See, like here it is, we will get the T1, T2, T3. Now we know the time period of oscillation, we know for 20 oscillation. Now what is asking? We need to find a what? Spring constant. For the spring constant there is a formula is there. K is equal to 4 pi square M2 minus M1 by T2 square minus T1 square. We know T1, T2, right? We know T1, T2, and T3 also we know. So that here in the formula is what is there? M2 minus M1 by T2 square minus T1 square. Now by using this, now here we should get in a calculation like it is. So we can take a calculation by using this, so that here we will get the T1, T2, T3, because is asking spring constant, no. For first one I am telling K1, you go for the K1, after getting K1, K2, K3, and you add K1, K2, K3 divided by 3, because we are taking the 3 readings now. So you go for the first spring constant, that is K1 is equal to 4 pi square into M2. What is M2 is given? 250 into 10 power minus 3 minus M1, 200 into 10 power minus 3 by T2 square, right, 0.82 whole square minus T1 square, 0.71 whole square. So that here we will get the K1 approximately equal to, K1 value will be equal to, see, after substituting this, see 11.17 it is Newton per meter, it is a K1, and you go for the K2, that is also 4 pi square into, again here it is actually M2 minus M1, no? Next one you take as, it is will be M3 minus M2, M3 minus M1, right, it is M3 minus M2, sorry, M3 minus M2 by, it is T3 square minus T2 square. So again you substitute here, K2 is equal to 4 pi square, M3, what is M3 is there, it is 2 and 300, no, so 300 into 10 power minus 3 minus, here it is M2, no, that is 250 into 10 power minus 3 by here T3 square minus T, 0.94 whole square minus 0.82 whole square. Again you simplify this. See, K2 is equal to, after simplification, K2 is equal to 15.18 Newton per meters. This is K2. Now go for the K3 also. So K3, for K3 you say directly we can take M3 minus M1, right? So that here T3 minus T1. It is K3, no? Therefore K3 is equal to 4 pi square of M3. What will be the M3? 300 into 10 power minus 3 minus 200 into 10 power minus 3 by, here it is T3, that is we can say 0.94 whole square minus T1 is 0.71 whole square. So that here is the simplification. After simplification we may get 12.80. Now we know K1 we know, K2 we know, K3 we know. Now we need to find a approximation, that is spring constant, no? Therefore add 3, K1, K2, K3 divided by 3. Therefore we will get the final answer. It is we can see. So this is an actually force constant. See, spring of force constant it is. So K is equal to K1 plus K2 plus K3 by 3. So that here K is equal to, K1 will be 11.17 plus K2 will be 15.18 plus 12.80 divided by 3 you take. So approximation we may get the 13.08 it is. So this is Newton per meter. This is the spring constant of a given a helical structure of a spring constant. Helical structure of a spring constant it is. So this is the experiment related to force constant. So like that we can find the given a force constant of a given a spring K. So this is the method to get the spring constant. Okay. So this is the experiment related to the force constant. Right. So you go through this video and properly you see the video, and you have a manuals. Once you read the manual, in the manual also, and you go through the video also, you will get the clear information by this video. Okay. Thank you very much. We will see in the next with experiment, new experiment. Thank you.